Hello, everyone. Welcome to Clay Loves Logic. On this channel, I solve logic-based Sudoku puzzles I find interesting. Today, I'm going to be looking at the puzzle German Beetles by Katie Splendor. As always, I'll put the link to this puzzle in the video's description. And with that being said, let's get into the rules. There's a lot of them today. Okay, what do we get? Normal Sudoku rules apply. You have to have the digits 1 to 9 in each 3x3 box, in each row, and indeed, in each column. Each digit along a green line differs in value by at least 5 from its neighbor. These are German whisper lines. We've seen these a number of times on the channel at this point if you've seen any of my videos. But if you haven't, what that would mean is this digit needs to be at least 5 away from these two digits. If this was a 1, these could be 6 and 7. This would have to be, well, 6 is a bad example, but we'll talk about why later. If this was a 1, these could be 7 and 8, these could be 2 and 3, etc., so on and so forth. White Kropke dots separate cells with a value difference of 1. These two digits are consecutive. 1 and 2, 2 and 3, 3 and 4, anything like that. No negative constraint on those or black Kropke dots. And there is no black Kropke dots. I don't see any. So, okay. Two cells separated by an X. Excuse me. Two cells separated by an X sum to 10. These two digits. This could be 6, this could be 4. Something like that. Two digits separated with a V sum to 5. 1, 4, 2, 3. No negative constraints. Now, what no negative constraints means, if you're unfamiliar, is just because there's no V between these two digits doesn't mean they couldn't sum to 5. Coincidentally, these could. This could be a 1, this could be a 4. That's allowed in this puzzle. Sometimes you'll see puzzles where there are negative constraints, and so for something to sum to 5, it would have to have a V between it. That's not the case in this puzzle. Digits in killer cages are distinct and add up to the value in the left upper corner of the cage. So these two digits sum to 12. So do these. No, okay. Thermometer lines strictly increase in value from the bulb end. If this is a 1, this could be 3, this could be 5. And thin gray lines without bulbs are palindromes, and they read the same in either direction. What that means is these two digits are the same. And these two digits, if I could grab them, those two are the same. And those are the rules of this puzzle. So let us get into it. And I'm going to put in a 1, 2, 3, 4 for this 5 pair. And I think I want to start with the 14 cages first. Those are the biggest ones. So a 14 cage only has a couple options, right? You could use 6, 8, or you could use 5, 9. Now, one thing we know about German whispers is you can never put a 5 on them. And the reason that's the case is because if this was a 5, what could you put on this digit that's 5 apart? You'd have to put at the smallest a 0, or sorry, at the largest a 0, 0 or 10, or higher than 10 or lower than 0. But of course, none of those are valid Sudoku digits. So if this isn't a 5, this is not a 9. The same thing can be said here. 5, 6, and 8, 9. And again, this is not a 5, so this is not a 9. This is consecutive with the 5, or with the 5, 6, 8, whatever this is. So this is, you know, a whole heap of things. I'm not going to pencil mark in yet. Sorry, excuse me. I will do the 1, 2, 4 that sums to the 6, 8, 9. That would make this 6, 8, 9, and these are the same digit. Same thing exists here. 6, 8, 9, 6, 8, 9, 5, 6, 8, and 1, 2, 4. Hey, what happened to my 1 and 2 here? Okay, if this is 6, and this is what I wanted to get to about this, right? If this is 6, this is something to note about German whispers is if you have a 6 on it, 6 is a monogamous digit, so is 4. And what I mean by that is 6 only has one friend. If you have a 6 on this, and you have to have digits differ by at least 5, you could only have a 1. So the fact that there's 2 places this German whisper needs to go to means we can't have a 6 on it, because we can't have double 1s. So in fact, we take the 6s out of there. We take the 4 out of here, and we take the 6 out of here. And then because we take 6s out of a 14 cage, we take 8s out of their friend. That's not that. That's not that. This is not a 4. All of a sudden, this is 4, 5, 6, 7. I feel like that's a reasonable thing to put in. 8, 9, 5, 6, 4, 5, 6, 7. Sure. Okay, so now we can look at these digits. On a German whisper, one of them will be 8, one of them will be 9. So this digit here could be anything from 1, 2, 3, all the way up to 4. These two, they have to be at least 5 apart from 8 or 9. So they could be from 1, 2, 3, or 4. And then this digit has to be a high digit that has to complete the thermometer. And when we look at what we have here, we have a 1, 2, 3, 4. So we have 3 of the digits 1 to 4. So we have 5, 6, 8, 9. So we have to have a 7 somewhere. And then we have to have some digit that's less than that. So we need one more digit from 1, 2, 3, and 4, and we need a 7. So how could this be the digit? How could this be a 7? It can't. This is the 7. And the 7 is going to take the 3s and the 4s out of the German whisper, because 7 would have to go to a 1 or a 2. Which means these are from 3 and 4, which means because this is a thermometer and they have to increase, it's going to be 3, it's going to be 4. And this is just a copy of it. So we know that this is 3, 4, 7, and we know this is a 1, 2 pair. It just has to follow the exact same logic because of the cages. That's really, really interesting. Yeah. Okay, so what can we say about the 12 cages? And unfortunately, there's quite a few more ways to make 12, but we should still be able to make good work of it. 3, 9, 4, 8, 5, 7. 5s come off here, so 7s come off here. And so we can't have a 4 on a German whisper for the same reason we can't have a 6. If we have a 4 here or here, what pairs with it? 9. And we'd have to have double 9s. We also can't have 4s here because of the 4s we can see, but that's okay. So when we're making 12, if we can't have 4, we can't have 8. We can't have 3 in any of these, actually, because this 3 sees those and this 3 sees those. So 3s come out. If 3s come out, 9s come out. And now we just have 7, 8, and 4, 5. And we're going to have the same 3 logic, aren't we? So this cage, they're going to just be mirrors of each other, which is so cool. I really think that's just neat. Okay, these digits can be max 1, 2, or 3. And there's no restriction yet. This digit has to be higher than 7 or 8. It has to be 6 or 9. And in fact, because there's 2 digits that go to it, it is a 9. And this is a 9. And now that 9 is going to see these 8s, which is going to see these 2s and do these 8s. The 8s are going to give us 6s. Wow, the symmetry in this is just beautiful. It's going to give us 9s, which pair with 5s, which gives us 4s, which gives us 8s, which gives us 7s because there's 9s already, which gives us 7s, which gives us 5s. Oh, gosh. And then we get a 4 because we can't put a 6 there. Wow, what a nice puzzle. Okay, so what do we need? We need 1. So this can't be a 3 anymore. So what's left? 1, 2, 3, 4. Hey, just low digits? No, 1, 2, 3, and 6. That's so nice because that's going to do the same thing that we have to have a 6 here. Because this digit has to be from, 1 or 2. This actually is just from 1, 2. They both see 3s. So these are 3s. Did I get the right one there? Yeah, going into the 7? Yeah, I did. Oh my goodness. I hope I didn't mess that symmetry up. No, I don't think I did. Just puts a 3 somewhere over here, which is fine. A 1, 2 pair actually makes this a 3, 4. Yeah. And then that's going to give us a 3. This 4 gives us a 3, which gives us a 4 and a 3. And this puzzle's hilarious. Oh, and look, this can't be 4, 5, or 7. This just has to be 6 for so many reasons. Oh, goodness. Okay, look, we have a 1, 2 pair, and this C's a 4. So this is a 3, and this is a 2. And now we have, that's a 1, that's a 2, that's a 1, that's a 2, that's a 2, that's a 1, that's a 1, that's a 2. Oh, gosh. So this can't be 4, 5, or 7. This is 6. Look at that. 5, 6, 5, 6, 7, 8, 7, 8. This puzzle's hilarious. 3, 6, 8, 3, 6, 8, 2, 7, 5, 2, 7, 5. 168, 168, 439, 439. Wow. So what is this going to be? This is just probably a 2, I bet. I don't know. What do we need up here? We need 1, we need a 2, and an 8. That's all we need. This is a 2. So this is an 8. What do we need here? 1, 2, we need a 3, which is here. And we need a 5, which is here. What do we need down here? We need 1, 4, and 9. That would give us, look, the palindrome says I can't be a 1, I can't be a 4 or a 9. I'm double ones. Oh, which means I'm not a 9. If this was a 9, it would have to pair with a 1, and it can't because there's 1 there. This is a 4, this is a 6, this is a 9. Oh man, what a puzzle this is. This is such a good puzzle. I'm having so much fun. What is this digit? 1, 2, 3, 4, 5, 6, 7. This is an 8. This is 1, 2, 3, 4. This is a 5. Up here, what do we need? We need a 1 in one of 2 places. Can this be a 1? It can. 1, 3, 4. It's not in the middle. 5, 6, 7, 8, and 9, which is somewhere over here. Oh, and this can't be a 4. Look at that. If this was, yeah, so this is just ones. So this is a 9. This is a 4. Up here, we need 1, 2, 3, 4. We need a 5 in this box. Somewhere here. We need a 6 in this box, somewhere here. We need a 7 in this box, somewhere here. And then we're going to need a 9, aren't we? We probably need the same, if we do need the same digits here. What is going on? This puzzle is loopy. This has to be the 5, 9, isn't it? Yeah, of course it is. And then this is going to be the 6, 7. And that's going to, we have a 6 there. 7, 6, 7, 6. So what is this? 5 and 9 and 4. This is a 4. This is a 9 and this is a 5. And this is a 9. And this is 5. And this is a 9. 1, 2. We need a 3 somewhere in here. It's only there. We need 1, 2, 3, 4, 5, which is going to be here. And we need 1, 2, 3, 4, 5, 6, 7, which is just here. And we are just almost done this puzzle. A 1 goes there. And a 2 goes there. And 1, 2, 3, 4, 5, 6, 7, and an 8 goes there. 13 minutes, 16 seconds. 1,904 people have solved this puzzle in 32.6 days. I can see why. This is an excellent puzzle. Katie, Splendor, what a great puzzle. It's not often I solve a puzzle and I just find myself laughing, but this puzzle was such a treat. The symmetry was so much fun. 275, 275, 861, 861, 439, 439. Really, really nice. Really, really nice. 368, 368, 940, 940, 507, 507. Wow. 149, 149, 357. That's just, that was a great puzzle. I hope everyone enjoyed watching it as much as I enjoyed solving it. And I will catch you all on the next one. Thanks.